Hey guys, here's a little help for DCP24. It says Lindsay's flying a kite at the end of a 250-foot length of string. The position of the kite is directly above Lindsay's little brother, who is standing 80 feet from Lindsay. How high is the kite? Or how high above the ground is the kite? So what we have is a right triangle. And let's draw a right triangle. Actually, let's bring this up a little bit. Okay, so let's notate that we have a right angle there. And it says the string. So here's Lindsay down here. So let's make a dot down here where we see Lindsay at. And then her little brother is right here. So he's 80 feet away from Lindsay. And of course up on top is the kite that's flying high right up here. It says the string is 250 feet. And the brother is 80 feet away. So that would be the diagram that would model the situation. Now it says what angle is formed? What angle is formed with the ground and the string? Okay, so basically what they're looking for is X right in here. Alright, so it says what angle? Round to the nearest tenth. So we're looking for this angle right in here. So that's the X we're looking for. What angle is formed by the kite, string, and the ground? And so this one, with this angle right here, the 80 is your adjacent side. So this is the adjacent down here of the X. And of course the 250 is our hypotenuse. It's always a hypotenuse. Anytime you're looking across from the right angle, you're always going to have a hypotenuse. So AH, if you look it up here at the top, the A and the H would be the cosine. So we want to do cosine -1 because we want to find the angle. So we need the inverse cosine of, for X, inverse cosine for X to be adjacent 80 divided by the 250. So you're going to get a decimal in your calculator and then put the inverse cosine, and that'll give you your angle. That'll give you your X. How high is the kite? Let's make that a Y value. So the height of the kite from the base and the height right there is the right angle. You got a few options. You can use your angle that you just found and do SOH, opposite over hypotenuse, or what might even be more popular would be the A squared plus B squared equals C squared. So in our case, we would use the 80 squared plus the y squared equals the 250 squared. Okay, so that's how you set up the number letter C there, and you just solve for y. Or you can, like I said, you could use this angle and do sine of this angle equals y over 250. That'll still work. Now it says, suppose the winds begin to calm and the kite string forms a 55-degree angle with the ground. So what happened is that the kite started to fall. It means this started to come down like this. So now your right angle's over here. You're not 80 anymore. The bottom's not 80. What you have is basically a 55-degree angle down here. .55 degrees here. The string is still 250. That has not changed. Still 250 feet. And they want to know the new height. So that's what you would be looking for in that one. So that is the first part of your DCP24. All right, here's the second part. Is about the Leaning Tower of Pisa in Italy. Leans at an angle of 5.5 degrees off of vertical. On a sunny day when the angle of elevation of the sun's rays is 68 degrees, the tower casts a shadow of 27.8 feet long. All right, let's start with a right angle. Let's start with a right angle. I don't really like it that direction. Let's flip it around here. Okay, so a normal building would be at a 90-degree angle. This building right here leans at a 5.5 degrees off of vertical. So 5.5 degrees is not a huge angle, but it's big enough to make a difference. You can actually tell it's leaning. You can see the building, you know it's leaning. That just means to us that this angle down here is going to be 84.5 degrees. And how I got that was because I just did 90 minus the 5.5. 90 minus 5.5 is going to give me the, don't like that kind of writing. 90 minus 5.5 is going to give me the 84.5. So that means this first angle here is 84.5. Now it says the sun's rays are coming down. Sun's rays are coming down at an angle of elevation of 68. So right here it's a 68 degrees. What it's asking us for would be the 27.8 meters long shadow. What they're asking us to do here is use the law of sines. So this would be our picture that we would look at. Let's label these angles. Let's say this is A, this is B, this is C. What we would have right now, this would be little a over here. This would be little c on this side. And this would be little b down here. Right now what we have is an A, a B, and a C. So we technically couldn't use a law of sines because we need two of the same letter. But whenever you have two angles, you can take those two angles and subtract them from 180. So 180 minus 84.5 minus 68, and we will get angle B. So let's grab a calculator and we'll do 180 minus 84.5 minus 68, and it's a 27.5 degree angle. 7.5. Here, 27.5 degrees. Okay, so that's going to be our angle B. That goes right in here. Now we can use the law of sines, because now we have sine of B over little b. So we have the sine of 27.5 over little b, which is 27.8. And that is going to equal, and we want to find, what is it asking for? To write an equation that can be solved for the height of the tower. So we want to find little c. So little c, and we need the sine of c, sine of 68, over little c. There's your proportion that you set up, and now you can solve the proportion. You can multiply your diagonals. This would actually go down here. Sorry. So this equation right here, this proportion right here, you can now solve. C times the sine of 27.5 equals 27.8 times the sine of 60. Divide both sides by the sine of 27.5, you get your answer. So that's what you're going to do down here, is you're going to use this equation and solve it for down here. And that's it. All right, see you guys tomorrow.